Hello everyone, my team and I today we are going to discuss LED interfacing with microcontroller followed by 7 segment display and a program on it. So let's quickly introduce my teammates.
This is Ishwar.
This is Gopi Krishna.
And I'm Gokul.
Okay, now let's get into the topic.
Hi. Today we're going to make a presentation on LED. We'll be covering what is an LED, the working behind it, the implementation, like the modes of operation. Then we'll go to the circuit diagram, followed by the truth table of the 7-segment display and a program to implement it. Then we'll be going over why LED is preferred over other types of displays.
I'm going to explain you about what is LED. LED stands for light emitting diode. It works on a principle called electroluminescence. Now, before going to discuss about electroluminescence, we will discuss about charge carriers recombination. When a voltage is applied to a device, the electrons inside the device and the holes inside the device combine to release some energy. The energy may be in any form. The energy is in the form of photons. This is called, the principle is called as electroluminescence. So, like diodes may emit energy in any form. Only if the diode emits energy in the form of a photon, it will become LED. So all diodes may not be possible to be as LEDs. Now we'll discuss modes of connecting LED display. We can connect LED display in two ways. One is common cathode way and the other is common anode way. And the common cathode, all the cathodes are commonly connected to ground. In the common anode, all the anodes are collectively connected to power supply.
This is Ishwar, and I'm going to give a briefing on the modes of connecting a set of LEDs to a microcontroller or any other device. Well, we can see there are two modes of connecting a set of LEDs. It is a common cathode mode and a common anode mode. In the common cathode mode, we can see the cathodes are connected and are grounded, and the anodes are connected, given to VCC in the common anode mode. Well, this is a common cathode mode of connection of a single LED. Here we can see cathode is connected to the ground and anode is given to the output of a microcontroller. When the output of a microcontroller is high, there will be a biasing between the diode and light is emitted. So this is the way they connect in the common cathode mode. We can see this is a common anode mode of connection in which an anode is given to the VCC and cathode is given to the output of a microcontroller. When the output of a microcontroller is low, again there is a biasing between the diode which emits light, and again it is glowing. Well, this biasing voltage shouldn't exceed some optimum voltage. If it exceeds this voltage, it may damage LED. This is a full set of connection of a common cathode mode of a set of LEDs. This is used for this is a common cathode mode of connection of all the set of LEDs. This is used for a 7-segment display or 8-segment display. Now we can see it is connected to the input-output ports of the microcontroller. And when these ports are relatively high, then we can see a glowing in this set according to the program written or the want of the user. And this is the common anode mode of connecting the set of LEDs in the 7-segment display or 8-segment display.
This is the implementation of the 7-segment display. So this is the 7-segment display from A to F, A to G, then followed by the decimal point. So these 8 segments form the output pins of a port from the microcontroller. Now, if you want to display 0, all the bits except G should be on. So we'll be giving one setting the bits A, B, C, D, E, and F to 1, and G will be 0. Similarly, if we take an example of 6, all the bits except B should be glowing. So A, C, D, E, F and G are glowing and B is 0, and so on.
Hello, I am Harshavardhan. Now I am going to discuss about 7-segment LED display. These are 7 segments. Each line represents each segment. In general, microprocessor or microcontroller will be having a data transfer for 8 pins. So we do transfer data through 8 pins. Further, we need one more segment. Generally, we make that 8th segment as a dot. Now, based on these 8 segments, we can able to distinguish which number has been transmitted. For example, if you want to transmit 1, then B will be made to 1 and C is made to 1. Then 1 will be displayed. Based on this, truth table of this 7-segment display has been constructed. Now, I will discuss an algorithm and a program for 7-segment display. This is the program which we are going to discuss. Here, I have taken port 1 as an output port, and this is the 8-segment display, which includes dot also. See, here I am moving 03F, which is 3F, which is equal to 0. Here in this program, what the basic aim of this program is, it will continuously display 0, 1, 2, 3 and so on 9, and again go back to 0. This is the program which explains that continuity. And here I have taken delay as 1 second. For, as if I told in the describing the algorithm, if you want to have a 1, you need to display some kind of bits. Like that, for each number, these are the values. Based on the number you want, you have to send the required value to the port.
Okay, some of the advantages of LEDs. LEDs are environment friendly and easy to use. They are self-luminous, which means there is no need of any background illumination like the LCD monitor. LEDs give a bright and enhanced contrast light. Then LEDs are also compact, so we can make very slim displays, which is useful for many applications. Then LEDs are flicker free, which means there is no eye fatigue or strain, and we also have less headaches.